Let's be real for a second. Have you ever asked an AI to write some code and then spent the next hour just debugging its generic, kind of useless output? Yep, we've all been there. But what if you could build a system that automatically generates production ready code, code that actually fits your project perfectly? Well, today we're going to move beyond those simple little prompts and learn how to build a true AI code generation tool. Let's dive in. You know the drill. You have a pretty straightforward task, you give the AI a simple prompt, and what you get back is a simple and simply wrong answer. This is the core problem, the trap that so many of us fall into. We end up treating these incredibly powerful models like a basic search engine, when really they can be so much more. Okay, take this classic example. You ask it, write a function to validate email addresses. What you get back, it's technically code, but it's awful. It just checks for an at symbol. That's it. It misses dozens of edge cases. There's no documentation, no type hints. It is basically useless in a real world project. This isn't saving you time. It's just creating technical debt for later. So why does that simple prompt fail so spectacularly? Because it's a total shot in the dark. The AI has zero context about your project, no idea what you consider good code, and no process to refine its work. So here's the crucial takeaway. The solution isn't just writing a slightly better prompt. It's a complete mindset shift. We have to stop thinking in single prompts and start thinking in systems. Automated tools that orchestrate multiple prompts to get a high-quality result every single time. So what exactly do I mean by a code generation tool? Well, think of it as a system that uses really carefully crafted prompt engineering to automatically create code that's ready to go straight into production. This is way beyond just simple code completion suggesting the next word. This is a tool that actually understands your requirements, knows your project's coding standards, and generates complete, correct, and well-documented functions or modules. So how does a system like this actually work? Well, it's all built on four core principles. First, it has to parse the specification. That means breaking down your request into structured, clear instructions. Second, it adds context, things like your project's libraries and your team's coding style. Third, it selects the right patterns for the job. And finally, and this is key, it iteratively refines the output. It does this using something called prompt chains, where the output of one prompt becomes the input for the next, making the code better and better with each pass. All right, that's enough theory. Let's actually see what this looks like in practice. We're going to take that failed email validation example from before and run it through a proper code generation system. And trust me, the difference is night and day. Remember this thing? Write a function to validate email addresses. And it gave us this useless one-liner. It's the perfect example of what happens when you give an AI no context and zero quality requirements. You get the simplest, laziest possible answer. Now look at this transformation. Instead of a vague question, the system uses a highly structured request. It defines the AI's role as an expert developer. It provides a crystal clear specification with detailed requirements. And it adds that crucial context, like the project style guide. And the result on the right? That's production-ready code. It's robust, it's documented, it handles edge cases. This is the power of building a system. So you've seen the what and the why. Now let's break down the how. A proper code generation tool isn't just one giant prompt. It's actually made of several distinct components all working together. Let's take a look at the blueprint. A really robust tool has 6 core components, and they all work in sequence. Think of it like an assembly line. The specification parser figures out what you actually want. The context manager pulls in all your project info. The pattern selector picks the right code structure. The code generator does the actual writing. The quality validator checks it for errors. And finally, the output formatter makes sure it looks perfect. Every single part is critical to the final result. Now, all those components are powered by a really clear prompt architecture. You start with a system prompt, which sets the foundation. It defines the AI's persona and your high-level coding standards. Then you use a specification prompt that defines the specific task at hand, with all its inputs, constraints, and context. And finally, you use refinement prompts to review and iteratively improve the code, making sure it meets all your quality standards. They all work together in a chain to produce that amazing final output. Okay, now for the most exciting part. You now have the blueprint to build your own tools. The real goal here is to identify all that repetitive boilerplate code in your day-to-day work and create a system that just automates it away. That frees you up to focus on the truly interesting, complex problems. If you take just one thing away from all of this, let it be this. The difference between a frustrating AI experience and a truly game-changing one isn't the model, it's the system you build around it. A great system built on great prompts is what delivers those absolutely transformative results. So, where do you even start? Here are 3 pro tips to get you going. First, build a prompt library. Save your successful prompt templates so you don't have to reinvent the wheel every time. Second, use few-shot examples. This is just a fancy way of saying show the AI a couple of good examples of your existing code. It's a great way to teach it your specific style. And third, always include a final validation prompt that tells the AI to double-check its own work for errors before it shows it to you. And look, this isn't just some theoretical exercise. I want you to think about your last week of coding. Think about all those repetitive API endpoints, the database models, the unit tests you had to write. With the framework we just covered, you can actually build a tool to handle that stuff for you. So the real question I have for you is, what boilerplate are you going to eliminate first?